Okay, guys, this is going to be the first of two sets of notes from lesson 2-7. It's kind of similar to what we did earlier in the chapter where we talked about finding percents of numbers and changing numbers from fractions and decimals to percents and vice versa. And then on another day, we talked about, well, what if we have really large percents over 100%? And what happens if we have really small numbers, like less than 1%? So we, on Monday, are going to take notes on the really big numbers, really big percents, and really small percents. So today, we're going to be, oops, sorry, wrong color. We're going to be taking notes 2-7 on percent of a number. Now you might say, well, wait a second, isn't that what we just did notes on the other day? And the answer is yes, but what I'm going to do is teach you a different technique. Sometimes our numbers aren't always pretty or nice, and so I'm going to show you a different way where you don't have to try to manipulate the numbers to be the way you want them to be. Today's date is 12/7/18. So here's an example of the kind of problem we're talking about here. So we've got 57% of 12. So I'm trying to figure out this portion of the number 12, okay? So I can even, in my head, go, well, that's a little over 50%, and half of 12 would be 6. So my answer is going to be in the neighborhood of 6. That's what I'm guessing, okay? Now, a couple things. First off, we're going to do the problems using that word of, and we're going to change that into an operation, and that operation would be multiplication. So number one, we're going to use multiplication to calculate the answer. And if you think about it, that's what we were doing when we were figuring out 50% was 4/10%. So we did multiplication there. But the next thing is we have a bit of an issue, and that issue is right there. I actually can't do any math when there's a number with a percent symbol. So we can't calculate when there's a percent symbol. And so that's that guy right there. So we have two choices. Choice one, we're going to change the percent to a decimal. Okay, which we covered earlier in the chapter. And in order to change a percent to a decimal, we're going to take that percent symbol off, and we're going to divide our number by 100. Our second option is change to a fraction, change the percent to a fraction. And again, we're going to need to take our number, take off that percent symbol, and we're going to divide by 100, but it's going to look like this. So whatever that percent number was, so that divided by 100 vertically, okay? So those are kind of our two options. So we're either going to be multiplying fractions or we're going to be multiplying decimals. So we're going to review both of those. It's been a while since we've done all of that. So let's start with, on this side, multiplying fractions. So key ideas we're going to try to remember is we're going to try to divide out common factors of any numerator with any denominator. And this is what we call canceling. Okay. Now remember, there's 4 places to look. We can look on the diagonals, and that's where most people, that's the only place they look. So, because they're used to that term cross canceling, so on the diagonals. But remember, sometimes there's a common factor within the fraction itself, so always look there as well. So I always like to set up the problem, and I like to try to, what I call pre-reducing, so I'm going to put that up here too, just to remind you of my words. Pre-reduce. That means I'm going to reduce before I multiply, okay? Some people like to multiply and then reduce, okay? So then we're going to have 2 steps after this. Once we pre-reduce, then we multiply straight across. Straight across. So you're going to have numerator times numerator over denominator times denominator. Okay. And regardless if you do the starred, try to divide out the common factors of any numerator and denominator. If you don't do that before you multiply, you can multiply, but then and always you should double check your answer. Remember, we talked about stinky 3s like to hide out, so we have to look for them. Simplify if possible. It may not be possible because if you pre-reduced, then you may have caught all of the common factors at that point. Okay, so that's a reminder of how to do multiplying fractions. All right, let's do, and then let's talk about multiplying decimals. Okay, so going through the steps, number 1, when we're going to do this multiplication, we're going to just temporarily forget that there's any decimal places or any digits after decimal points and any decimal points altogether. So we're going to ignore the decimal or decimals and multiply the numbers. So we're going to write them vertically, last digit under last digit, and put the longer number on top, shorter one on the bottom. So ignore the decimals and multiply the numbers. Okay? And then you got to go back to reality, and yes, there really were some decimals, and yes, there really were some digits after those decimals. So now we need to go back and figure out how many digits are going to come after the decimal in our answer. So we're going to count the number of digits after the decimal points in the original numbers. Now, perhaps only one number has a decimal point. Perhaps it's only that percent number that has a decimal point. So you may only have to count the number of digits after one of the numbers because there's only one decimal point. Okay, and then we're going to use that number of digits that are going to come after the decimal point altogether to help place the decimal point in our answer. So the answer will have the same number of digits after the decimal. Now, what am I talking about? The same number of digits, what we counted in step 2. So I'm just going to put in parentheses step 2. Okay? So let's go back and let's look at that original problem, that 57% of 12, and let's solve it both directions. So with fractions, I would take 57 and give it a denominator of 100, and then I would multiply it by 12. So I'm going to make 12 a fraction by giving it a denominator of 1. Now I'm going to see if there's anything I can reduce, and I know that both 12 and 100 have a 4 in common, so 12 divided by 4 is 3, 100 divided by 4 is 25. And then we're going to multiply straight across, and we get 57 times 3. 3 times 7 is 21, and then 3 times 5 is 15, plus 2 is 17. And then I have over 25. And then what I can do is convert this to a mixed number. So 25 divides into 171. Ooh, man, that's just short of 7 times. It's only going to go in 6 times, which is 150, with a difference of 21. So I get 21 over 25 is my remainder. So the answer is 6 and 21/25. Okay, so what would the work look like if I was multiplying using decimals? Well, first off, I would take and move the decimal point from the percent left twice, which would give me 0.57, and then I'm going to multiply it by 12. So I'm going to pretend there's no decimal point, and I'm just going to do multiplication here. I've got 14, 10, and 1 is 11, placeholder, 7, 5. Add up, we get a 4, an 8, and a 6. But it really wasn't 57 times 12. It was 0.57 times 12. So I'm going to count the number of digits that come after the decimal point altogether, and I came up with 2. So my answer also is going to have 2 digits after the decimal point. So my final answer is 6.84. And now you might say, well, wait a second. Are those the same? Think about it. If I multiplied 25 by 4, I would get into hundreds. Okay, hundreds. So if I multiply 21 times 4, I get 84. So both of these answers are identical. They're just different formats. Okay? All right, we have one sheet of examples. So hang on, and we'll get right to that. Okay, so what we have here is a circle graph, and it says, refer to the circle graph. Suppose there are 300 students at York Middle School. Find the number of students that have cheese as a snack. So let's see if we can find cheese. And here's cheese, okay? So what it's asking us to do is to find 15% of 300. So I'm going to demonstrate how to solve that problem 2 different ways, okay? So let's start by taking that percent and writing it as a fraction. So 15% becomes 15 hundredths. Of means to multiply, and then we have 300 over 1. Then we look for anything that we can reduce, and oh my goodness, are we lucky. We've got 100 goes into itself once and into 300 3 times. So if I multiply straight across, I get 15 times 3 is 45, and the denominator would be 1, so I'm not going to do that. So the answer would be 45 students, have cheese as a snack. Okay. Now, I can solve that same problem, but instead of writing as a 15% as a fraction, let's do it as a decimal. So I move the decimal left twice, and I have 0.15 times 300. So I put the longer number on top, shorter number on the bottom, disregard the decimal point for temporarily. I get 0, 0, 15, put in a placeholder, 1 times 0, 1 times 0, 1 times 3. And then add up, and I get 0, 0, 5, 4. And now I have to go back and count. I see 2 digits after the decimal point, so my answer is also going to get 2 digits after the decimal point, and guess what? Yep, that equals 45. So again, we get exactly the same answer. So it's up to you to decide which strategy you want to use. 45 students have cheese as a snack. Okay, so as an extra bonus, they want us to find the number of students at the York Middle School that have chips as a snack. So let's find chips. Oh, here they are. And it says it's 18%. So let's write that over here. So we're going to do 18% of 300. Now, this one's nice because if I change it to a fraction, I get that 100 again. So I kind of determine whether I use fractions or decimals for my percent number based on the number that I'm multiplying with. So I'm going to rewrite this as 18 over 100 times 300. Well, that's a terrible 300. Looks like 800, doesn't it? And I always tried you guys about that. There we go. And then 100 goes into itself once and into 300 3 times. And so what I'm left doing, if I can't do it in my head, I can do it off to the side, is multiplying 18 by 3. So I get 24, 3 and 2 is 5. So then I would say 54 students have chips as a snack. Okay, and you can do this problem just as easily with decimals if you feel like it. But again, because the denominator 100 would go in perfectly evenly into that guy with 300, I just thought, ooh, I feel like doing that. All right, have fun tonight.